ladies and gentlemen, sehr geehrte Damen und Herren, bonjour, mesdames et messieurs. Welcome, my name is Sébastien Meunier, and as a chairman of the Expert Committee on Innovation, Upper Rhine Conference, I'd like to welcome you to this event, Innovation Without Border. The Franco-German-Swiss Conference of the Upper Rhine provide the institutional framework for cross-border cooperation in the Upper Rhine region, and the Expert Committee on Innovation is one of the 35 expert committees. I'm also Director of Industrial Transformation by Basel Area Business and Innovation in Switzerland. We are a non-profit organization dedicated to helping startups, institutions, and companies find business success in the Basel area. We help develop a robust business climate and support innovative venture. We attract and support companies moving into this area, connect organizations and entrepreneurs with collaboration partners, and help create a vibrant ecosystem that fosters innovation. So I would like to switch. Would like to welcome you on behalf of my colleagues on the committee. We are different organizations from Switzerland, Germany, and France. We are all part of the Expert Committee on Innovation from the Upper Rhine Conference. And please, partner, switch on your camera. We have Jean-Michel Sterle from Adira. He will just join later. We have Renato Janicek from Regierung Präsidium Karlsruhe. We also have from Basel area myself and Albert Hilbert and also Frédéric Nicolet. And from the Chamber of Commerce, Alsace Eurometropole, we have Eric Bonin. I would like to give Eric the possibility to say some words about the CCI Alsace Eurometropole. Eric.
Okay, thank you. Good morning to everybody. So many thanks to Sébastien for the organization of this meeting. Many thanks for our researcher. Special thanks as well to Université d'Haute-Alsace, our partner, and to all the participants. My name is Eric Bonin. I'm manager of industry and sustainable development at CCI Alsace Eurometropole, and we work to help the company for the transition of Industry 4.0, ecological transition, and for the promotion of the local industry know-how. So our target is to establish a closer contact and exchange between researchers as today of the Upper Rhine region and our local industry company. Two entities that do not know each other well enough, but have so much to share. We see as well that the company who work together with the research on Labo get the best. And for example, the best-in-class by us work with partner like Steinbeis, Fraunhofer, KIT. So our goal today with Basel area and our German partners is to help going in this direction of innovation without border in the Upper Rhine. So I wish you a constructive meeting and to identify new local and foreign Labo works solution on qualitative contact that can help you for the evolution of your products and services. Thank you.
Thank you, Eric. Now I would like to introduce Seren Akaba from Cyberforum on DE-Hub. Please, Seren. You are on mute. You have to switch on. Yeah.
Yes, thank you very much. Now everybody can hear me. Thank you very much. Also for this event and for the organization. Today I represent or replace my colleague Gennady Sherman. And yes, just want to say some words to Cyberforum and the DE-Hub. Right now, I'm sitting in home office in Karlsruhe, but normally Cyberforum is located in an old castle in Karlsruhe, and we are a non-profit organization. Since 1997, we were founded in 1997, and with more than 1,000 members, Cyberforum is the largest high-tech business network in Europe. And from startups and corporations, we try to bring, like over 20 years, all these partners together. And some words to the Digital Hub Karlsruhe for artificial intelligence. The Digital Hub Karlsruhe is one of the 12 hubs in Germany, which was elected from the German government for one specific excellence. And in Karlsruhe, this is applied artificial intelligence. And since 2017, the Digital Hub in Karlsruhe builds on the region's unique skills in the field of applied artificial intelligence. Yes, so that's from me.
Thank you, Seren, for your explanation. After that, we have the FVTM from Freiburg with Michael Richter. He will join us later, and I will give the word to to André Olveralens from the Chamber of Commerce Südlicher Oberrhein. André?
Oh, thank you, Sebastian, for the invitation. My name is André Vera Lenz. I'm working for Chamber of Industry and Commerce, Südlicher Oberrhein. It's located in Freiburg, Germany. We have 70,000 member companies, so we could have, or we have a kind of large impact. As Chamber of Industry and Commerce, on the one hand, we consult the companies in our region in environmental topics, in energy efficiency topics, Industry 4.0, digitalization, innovation, knowledge transfer. These are the topics we do in my business unit. I'm executive director for the business unit innovation and environment. And our target especially in technology transfer is especially to be a kind of multiplier between the research and development institutes and between the enterprises and companies in our region. And if it works, especially transnational. Thank you.
Thank you, Andre. So we have also Daniel Schäfer from the science pillar of the trinational metropolitan region of the Upper Rhine. So this is our group who built and defined this event. This is also the one of the first public action from the Interreg project Titan. This event was planned at the exhibition B 4.0 in Mulhouse, but cancelled due to the COVID-19. So we will use the breakout room with Zoom in order to create virtually the opportunity to discuss the small groups. So we believe that we have a great lack of exchanges between research and company yet. There are still great opportunity to work together. This is why we have decided to organize this meeting. I think we have to know people better before we can consider starting collaboration, a research, a project. This is why we offer you today 3 presentations by 3 researchers, 1 per country, and then the possibility in small group to exchange directly and concretely with them. Thanks the University de Haute-Alsace, IRIMAS Institute for joining us today. Thank also the High School Karlsruhe, Faculty für Elektro- and Informatiktechnik, and thank the University Basel, DB Institute for joining us. So our goal is to enhance the trinational activity with, for example, new contact, new know-how, new opportunity, and new innovation. We will present you shortly the program of today. and we will start picking with speech from Yves van der Ven from the European Commission. Then we will have a look at 3 presentations for 3 researchers and research activities. And as information, we will have Michel Basset. We do the presentation from Lassane Idougar from IRIMAS. Next, we will discuss more into details with all the 3 researchers in small groups. And finally, we make action with all the participants and a short conclusion from me. So we start with, I would like to introduce the next speaker. It's Yves van der Ven. Is head of sector digitizing European industry governance at the European Commission. And he will talk to us about the digitalization approach for recovery and resilience building in the EU. It's important to create a link between company researchers, but also with the European Union authority. So, Yves, it's your turn.
Many thanks, Sebastian. Good morning, everyone. So, just a word maybe about myself. I joined the European Commission in '98 with the research program and with a background of a polytechnics engineer. So I'm one of those rare animals in the Commission who is not a lawyer or an economist. And with this, let me share a bit the presentation. And so I have prepared here a presentation to guide you through a bit what can we do in terms of digitalization, in terms of innovation policy, in terms of capacity building, in order to make sure that not only we recover from the current crisis, but that we also prepare future-proof investment so that we are better prepared if such a crisis should happen again. You probably have seen that President Ursula von der Leyen, the President of the European Commission, made in her speech in September that we want to have Europe digital decade. That means by 2030, we need to see a much broader wave of digitalization, and we want to propel Europe really on a digital path. We started already in 2016 with a digital transformation initiative, Digitizing European Industry Strategy. Here, more than being historic, it also explains a bit the current approach that we have. So in 2016, we launched such an initiative. Industry means all sectors of the economy. I mean, we also not only thinking of the manufacturing industry, but also of the tourism industry. And what we aimed at by the time is really mobilizing 50 billion euro public and private investment, leveraging the investment of the European Commission, leveraging the investment of the regions and of the countries by private investment. 5 pillars, roughly a pillar on innovation, developing the basic building blocks of the digital technologies that we need, be it laser, robotics, microelectronics, artificial intelligence, high performance computing, but also a move towards industrial platforms. That is how we put the different digital components together so that they really perform a solution for businesses. So that is actually getting a step higher in the value chain here. not only we need to ensure the supply of digital innovation, and we talk of open technological innovation, autonomy now in the commission, but so the supply is important. We need to have the mastery, but we also need to make sure that there will be adoption of this digital innovation. And here we started with a concept which is a digital innovation hub, that is a one-stop shop, not-for-profit organization where SMEs can actually knock on the door and be helped with the digital innovation. They can test it, they can receive information, neutral information, or at least as neutral as possible, in order to make sure that the technological solution fits the problems of the SME, rather than being a vendor saying, yes, that's my solution and it will do good for you. So that's really the kind of things we have been developing. And we are now even one step further, because we, in the meantime, proposed the Digital Europe program, where we go systematically to develop digital innovation hub across all regions of Europe. And this is a point, and looking at who participates, that's something where indeed you might have an interest, not only to be supported by the hub, but also to see how you as a local hub can play this role towards companies. So that's really important here to lower the entry barrier for the traditional SMEs to acquire this digital innovation, and to really start making value-added products, changing processes, and changing business models. So we're thinking of servitization. As I said, we have now being a bit more systematic. And if I want to talk of the next programs, which we have put now on the table, you probably are more familiar with Horizon Europe. It's the follow-up of Horizon 2020, where here we aim at research and innovation. And when I say research and innovation, this is really where we want to see the mid to long-term research taking place. This is where we need to think of the next generation and the next to the next generation, for example, in terms of microelectronics. This is really where the research has to take place. And you have seen that now since about 7 years, we try to have half in research at low technology readiness level, and half a bit more closer to the market at higher TRL level. So that's really innovation action. We proposed also the Digital Europe program, and that's a bit the new kid on the block. It has now 7-8 billion, depending on whether you count in 2018 costs or 2021. And here, the Digital Europe program has a distinctive feature, which is it aims at building capacity. So we want to see the strategic capacities in terms of high performance computing, in terms of artificial intelligence. And with artificial intelligence, this is also related to the way we have access to data sets, the way we manage, the way we share the data, and cybersecurity. As part of the Digital Europe program, this is also where you will find now the place where we are going to systematically finance Digital Innovation Hub across all the regions of Europe. We have been working with the member states at the national level to have such a list of who should be the first digital innovation hub that would become European Digital Innovation Hub and would participate to the network. I will a bit come back to it. There are other programs which are also there where you can have also an interest. I will briefly mention them. The Connecting Europe facility, which is mainly about infrastructure 5G deployment, community Wi-Fi. So that's a bit where you will find this. There is a health program. Please make sure to watch out for what are the current negotiations taking place between the Parliament, Council, and Commission. Obviously, you know already of cohesion policy. You have had Interreg. This is getting now into a different kind of animals, which is probably much more interesting in terms of funding, which will be associated to it, which will a bit go beyond the pure coordination costs. But more importantly, in cohesion policy, you will see that the digital aspect has been really reinforced. So regional policy, regional funding is also a place to watch and to be in contact with your regional managing authority in order to make sure that proper project could also be launched. And another last program I want to mention is InvestEU. InvestEU is mainly a financial instrument program where it aims to directly or indirectly, that is through national promotional banks like KfW or BPI France, to invest as equity or as loans, as venture debt into startups to really create a tech VC ecosystem. The Digital Europe program structure is something which I mentioned already. We have basically three technology pillars, HPC, artificial intelligence, cybersecurity, and I wanted to mention the data space. The data space is really how to build platforms. And when I mention platforms, we all know the consumer platforms like Facebook, Amazon, and so on. The thing that we have also to realize is in Europe, the manufacturing industry is very strong. And we need to be able to make something out of the industrial data. And an industrial data is where we still have our strengths. So how can we make sure that we give our companies the necessary tools to exploit, to create value out of data, and to be able to share data along a supply chain in a way that it can be trusted and where there are fair mechanisms for compensation. So it's not just one of the actors in a supply chain or in a value chain taking all the value out of the data, leaving, for example, the creator of the data without compensation. So this is the kind of things that we are also now trying to put forward. And here, beginning of next year, there will be a data act that is how can we share data under which condition. That's something in terms of regulation which can already start to unblock some of the obstacles that we would have today. Here I have mentioned mainly the programs which comes out of the Commission budget. It is important to realize that apart from this 1 trillion something budget, which is used for 7 years to finance Commission programs, European programs, there is exceptionally this time also an instrument called Next Generation EU, which is an out of budget. That is, it's not part of the budget of the normal European programs, where we would use as Commission the budget, the MFF, the multi-annual financial framework, in order to go on the capital market and to raise money that we will be actually then using either as top-up to current programs. And you see that Horizon Europe would benefit roughly from a top-up of 5 billion. but the majority of it will be, in fact, used for member states, half of which in grants, half of which in loans. But then the member states can actually take the opportunity to redistribute that as other instruments as they see fit. But that would be here money that will be transferred to member states rapidly. I mean, it needs to be starting already in 21. It will have an effect 21, 22, 23. On the basis of a recovery and resilience plan that the country will come up with, saying, look, this is where we think that the cash injection is needed in my economy today in order to recover. There are also other instruments to cover for liquidity problems of companies, but most importantly, to see how we build a resilient economy, how we can actually lift all the boats in a broad digitalization wave, so that we see really here a major step change in the way we have a digital economy. It doesn't help if we have supported the digitalization of only one company in a value chain, if the whole value chain doesn't digitalize. So that's really here the important message that is behind, and is a bit also my plea to reach out to the national authority. You probably have seen the Plan de Relance from the French government. You probably have seen also the plan that was submitted in June in Germany, where there has been already funds allocated to this. I know that it has to be revised, and they are been proposing draft plans, and there will be final plans to be submitted in January, as of January this next year. So it's a plea to reach out to your people in the ministry to make sure that indeed the actions that will be proposed to be financed under Next Generation EU, under the Recovery and Resilience Facility, would in fact help to achieve this digitalization of the economy. 20% has been earmarked for digital. And here I want to mention, this is really the European Council conclusion of beginning of October. It says 20% for digital, including SMEs. So the SME dimension is here very important. And this is the most difficult part, is how you reach out to traditional SMEs, how you help them to uncover the unknown unknowns. So that's really here the difficulty. And this is why having this merge between academic networks and business networks is a good step in order to reinforce this. And this is where you have a role to play. Your strength is also the fact that you can act across different regions. So I really want here to say, don't only look at what is currently happening in terms of EU program, have also a look at what is out of program, the Next Generation EU facility, because it's really a unique opportunity to have very quick cash injection to get to a digital economy. And with this, I will finish. This is the kind of messages that I wanted to pass to you, that first of all, there are European programs. There is the Research Innovation Program in Horizon Europe with a number of topics in partnerships. There is the New Kid on the Block, the Digital Europe program, and there is the Recovery and Resilience Facility, which will be implemented by the member states. And now I hand over to you, Sebastian, if there are any questions. Many thanks.
Thank you very much, Yves, for the practical presentation. Maybe we can take one question if we have one from the publicum. It was very clear, but we could have some question. No. So I would like to thank you, Yves, very much for joining us and for giving us this presentation. And you will provide us the PDF of the presentation so we can have a look after that.
Certainly. Yes.
Thank you very much. Thank you. And you free if you want to stay. It's a pleasure for us to have you with
Thank
us.
you, Sebastian. Have a nice day. Have a nice workshop.
Thank you, Yves, and I will move forwards and come to the next part of our event and give the word to our researcher. And we will start with Michel Basset, responsible from Project Smart UHA by IRIMAS and the Université de Haute-Alsace. So, Michel, you have 10 minutes to present your research and your focus.
Yes, you can maybe see. Yes.
Yes, we see it perfectly.
Yeah. Okay. Well, good morning, everyone. My name is Michel Basset. I'm a professor. Oh, sorry. Yes, I'm professor in the Université de Haute-Alsace in Mulhouse, two towns, Mulhouse and Colmar. And I will present to you some of the research works made in our institute, but also a framework and also a platform which named Smart UHA. And I will give some details about this platform for works on the artificial intelligence and also on different problems with industrials. Yeah, in a few words, the different research thematics of the institute is in mathematics and computer sciences, and also automation and image processing. And the institute includes approximately more than 150 people, and you can see here the different people which make the institute. And our research activities is all the worldwide, and we have main activities in these domains, and we have also collaboration with academic laboratories, and also with industrial partners and different things like that. And we are also involved in different research projects, international one, and also national and regional ones. And we have also different trinational projects, and I will give some just examples just after in the next slides. And you have here an example of all the different industrial partners where we work with. And these partners are in different application domains. And you have a lot of partners in the transportation, but also in energy domain. And I give now some experiences with the different teams. I have picked up the research activities which are in link with our thematic today in artificial intelligence, and also in energy and transportation mobility. And one of this research team is Omega team, and the objective of this team is optimization by methodistic and algorithm modeling aspects. You can see here the different research topics of their research activities, and this team is led by the Professor Lassan Idunga, which is also the director of the Institute IRIMAS. And the research topic is, as you can see, mainly dedicated to optimization by different ways like deep learning, machine learning, meta-heuristic, computer, and applied also to computer vision, computational geometry. And today I will explain a little bit more applications in mobility transportation, but they also work on chemistry and surgical data science, medical data, and electrical engineering. Another team is also in the telecom and network domain. And this team is working on the complexity and also the guarantee to connect a vehicle with infrastructure, considering also, for example, mobility aspects. For example, if we in town, we want to reduce the number of vehicles, we can imagine to share the vehicle. And if these vehicles are autonomous, that means that we can test and you can propose and test some autonomous vehicles in a quarter of a town, and which can be ordered by demand and mobile domain. And in this domain, this team is working on the routing and also the link for that aspects. And we have also a collaboration with them, with work which is dedicated to the risk level assessment for driver automotive. For example, if we can imagine that all the different vehicles are connected and with infrastructure, for example, with signs, something like that, we can imagine that we propose services to the drivers, for example, by giving some risk level assessment for that. And they are working also on the domains of connectivity, latency, also reduction in the 5G for automotive networks. And they have also a big experience in VANET's application. These research activities are made also inside this Interreg project. It's an Interreg project between different partners from Germany, Switzerland, and France. And it's named Sumo Rhine, and this Sumo Rhine project is dedicated on sustainable mobility. Maybe we will have opportunities after to discuss about, to give some details about this Interreg project. This Interreg project is now began from more than 2 years, and they will go on 1 year more. And we imagine for a following of this project. Another example which is using artificial intelligence is IMT team, and this is dedicated here on signal processing for smart grids and smart buildings. And I will discuss about it in the Smart UHR project, because here we can connect all the different tools and services which are developed by this team with interest of, for example, the using of transportation like autonomous robots, for example. We can connect this interest all together. For example, we can imagine that for the smart grids, we can do here different to develop different tools, for example, to give a better signal processing for the electrical network. The electrical network has suffer some problems about some interferences, etc. And with artificial intelligence, we can propose some tools which are cleaning, or I can say like that, yes, we are cleaning the electrical networks to have a less loss of energy, for example. And also for smart buildings, we have also using the artificial intelligence to analyze in real time and to make some classifications about the using of energy in buildings. And we can give some signatures of different materials, different materials inside the building, etc. And we can have a more management, a better management of the buildings, considering this database and analysis which you have made here. And the MEM team, I know better this team because I am the leader of this team, is more dedicated on a transportation system. And we propose now for more than 20 years some different solutions embedded for autonomous vehicles. And we have developed some different experiences with, for example, like you can see here, some different embedded systems to give some autonomous vehicles. And we are working more exclusively on the perception of the scenes and also on the command of the vehicles, considering, for example, other objectives of the people. For example, we can imagine to give some different connected autonomous vehicles which can respond to a demand of the people. And this vehicle can, for example, wait you at the station of a tramway to pick up you and to give to bring you at your destination, final destination. That the different solutions are developed for the first and but also the last kilometer, considering the existing transportation system in town. And we have developed for that, you here, for example, is here for disabled people. And we have proof that it's very possible to apply this kind of solutions for disabled people. Here, for example, you have the system to take the chair of a disabled people, and disabled people can take lonely an autonomous vehicle completely. And you have also, you see, also the different solutions for electrical chairs, which are also tested for these people. And finally, I will discuss just a little bit about this robot, which is now is working now on the campus of the University of Alsace. But I give more details just after. Yes, the program of the Smart UHA platform and also project is to give some different services, but also to test different research works and also to permit to different industrial partners to test different solutions, embedded solutions, but also supervision solutions. Here you have a bird view of the campus of Hilberg in Mulhouse. And in red lines, we have drawn the different lines which will be deserved in the next days by autonomous robot. This.
Sorry, Patrick. Michel, you have 2 minutes left.
Yeah. Okay. No problem. And by this robot, and we will test from this research works all the different, for example, new perceptions algorithm, but also new command systems to avoid people, for example. It's a real life platform because it's a real life campus, and we will test with this platform the transportation system with robots, but also all the different buildings. These buildings and this one and this one are instrumented to see and to analyze and to give some services for the analysis of energy spent. And this smart UHA platform is used for validation of fundamental researches, but also to collect data and analysis from experiments, as different experiment is made every day, and we can collect that one. And we can share this platform with companies for technology transfer, for example, but also we have also with first collaboration with international academic partners. For autonomous electrical vehicles, for now, we are developing with partners some new algorithm, for example, to do some avoiding sequences, considering people who are crossing, etc. And is, for example, is a kind of example of this such an application. You have also here a more detail of this robot. We have here all the different sensors we can find inside the autonomous vehicle. We have a laser, radar, and inertial sensors, etc., etc. And we can also we are testing also new solutions with, for example, new cameras to see what this can bring to new solutions. And considering smart grids and smart buildings, we have also tested, but it's a POC, a proof of concept, to see what is possible to do with the link and the mix between different energy sources, and also to store the different energy, considering, for example, the demand of energy and also the building.
Hein?
No.
Sorry. And we
Ouais,
have.
j'essaye. Hein. J'ai un ordinateur, sur l'ordinateur, genre.
Oh, can you switch off your
Yeah.
microphone, please?
Thank you. Yeah. And we have two campuses which are used to test these solutions. And all these solutions are can be shared with industrial partners if we want to test some different things. And finally, the smart UHA objectives is to work with vehicle parks, but also on wireless network connections, and to see all the different items you can see here. For example, to study the low and low cycles for parked vehicles, study the vehicle to grid, etc. And we are also now created a shared database to be used by scientific community, but also if we some partners are interested by this data, is very useful, for example, to share all the different data. And also is also to study the human behavior in front of robots in real situations. For example, how these different behavior of the people, pedestrian people, who will react with some autonomous robots. And we are studying this aspect also. And sure, to study also the man-machine interface in real-life situations. And for socioeconomic aspects, yes, issues is to tackle acceptation, law, but also regulation adaptation. We are working for now with lawyers, considering also these aspects, considering this aspect with autonomous vehicle. And you have also the following different items we are using. I think I have finished now, Sebastian.
Thank you very much, Michel, for your presentation. Could we share your presentation with all the participants after the meeting?
Yeah.
Possible?
Yeah,
Yes, thank you. So we will have time in the different workshop for questions. I will hand over to Franz Quint, Professor of Communication Engineering at the Karlsruhe University of Applied Science. And Franz, are you here? And
yes, I'm here.
Thank you. And Michel, can you stop sharing? Thank you very much. Perfect. So, Franz, I would let you introduce yourself and make your presentation. Thank you very much.
So thank you very much. My name is Franz Quint. I'm from Karlsruhe University of Applied Sciences, and there I'm Vice President for Research. So in fact, I represent a whole university, but today I will rather focus on one research institute, on the Intelligent Systems Research Group of our university. Okay, where we work in applied and in research and in transfer of the research to the companies. I will rather take a fast ride to my slides considering the advanced time, and then maybe we can discuss in the group. So I will a little bit focus on the results. Here we are several people in this research group, 3 professors, several PhD candidates. And today I will address 4 topics, which are 3D morphable models, 3D people detection, simultaneous localization and mapping algorithms with planoptic cameras, and materials and process control. One project which I want to talk about is creating 3D morphable models from scans. So there are scans of peoples in different positions. They are without markers on them, and out of this, with neural networks, we learn to move these models or to morph them. It's the best way to see that in an example. So here there are 5 models created out of a large number of peoples, for example, making a movement, yeah, which is completely calculated, and you see it looks quite natural. This is learned out of static positions of people, and we have been able to reduce the density of the grid of on the surface. So here is our model, and in comparison to the so-called simple data set, which is a quite well known in this area, you see that our grid is much less dense, which means that we need much less computing capacity, and still we are able to perform similar movements with that, yeah, with a high accuracy. Okay, another project is to measure the head asymmetries of babies after birth. It often happens that they get born with an asymmetric head, and then they need a therapy in form of a helmet. But in some cases, this is also possible by using a pillar and the normal gravitational force of the head to bring it in the correct form. But then it needs to be monitorized in a very dense way. So we are building a mobile app on the phone so that the parents can monitor the progress of the therapy. Another point is 3D people detection from a bird eyes view. This doesn't work very well with the classical neural networks like YOLOS. You see there that they have that it has problems because these have been trained from front views, and now we have used artificially generated height data, distance data to retrain the networks so that now it is able to follow the people's move. And this, for example, even today in the times of COVID, it is possible to watch the distances between the peoples and detect the privacy or the proximity of them. Another topic would be SLAM, which stands for simultaneous localization and mapping, which means that we move with a camera through our environment and without any additional means for positioning like GPS or like an inertial motion unit, but just with a camera, we estimate the 3D model of the world and also the position of the camera so that we can build a map. We are using for this so-called planoptic camera, which is a monocular camera, but it has a micro lens grid on it so that you can perform stereo, in fact, with that camera, with a single camera. And this is beneficial in situations where you need a small weight and a small size of the sensor, like, for example, assistance for blind people, where you have to mount it somewhere in the glasses or on the head of the people. And depth can be estimated from a single image. We have developed there a model. I will skip over that. It leads to an array of cameras, and by using this mathematical formulation, we can estimate the depth even from different positions of the camera. so that we get a better accuracy, because due to that micro lens array, the stereo distance or the disparities are very small, are in the range of micrometers. We can improve that. And I present you one result here. This is a trajectory. Well, we made several trajectories, but here, for example, one, a path length of 240 meters, where we run around that building you see over there. And we start, it is, of course, a big challenge to see how accurate this is, because you do not have any ground truth of the scene around you. So we start in one point and we come back to the same point and see how the 3D models from the first recordings and from the last recordings fit and come to the same position. So we see here an example. In the upper left, we see the raw image. On the left side, then in the middle, the depth map. And then there's a so-called the image, the synthetical image, which is totally focused. And in the big image, we see how the 3D model builds while we run through the scene. The red point is the camera which goes. The green line is the estimated trajectory. And in white, the white points you see are the 3D scene points which build up. So we started at one point and now we are coming back to the same point. You see in front of those post boxes, and after 240 meters, we have a repositioning error of about 1.5 meter, which is quite good for working with any navigational aid or with any inertial motion unit, but just based on a monocular camera. We also have here another scene. It is an indoor scene where we are in a laboratory, and we get that again. The red cone is the camera and the view angle of the camera. And now we move through that laboratory and build the 3D model. And again, we come back to the beginning point and we see, of course, there is a small drift in scale. You see that at the two oscilloscopes, but in fact, it's good. Here, another one where we ran over several floors of a building. Steps down to a lower floor. Coming back. Okay, and we are again at the starting point of the scene. So the video just repeats. I stop at this point. And last point would be machine learning methods for material design and optimal process control of production processes. The idea behind this is if you have a chain of treatments of material, like for example, heat treatment, then a deep drawing machine, and then the welding in automotive industry production. Currently, they just are 3 separate processes, but using the knowledge from one process or maybe some imperfections or mistake perturbations which have been made in one process, you can consider them in the next process and make that optimal, or make a part, for example, of that heat treatment during the deep drawing by using or by choosing other forces to work. For example, the so-called blank holder force, which has to be chosen carefully, because if you choose it too small, there happens some wrinkle. If you choose it too large, then the material gets broken. And of course, you cannot explore the whole parameter space for the different materials and for the different objects. So the idea is to learn it with a neural network and to find the optimal setting for example, a selected height of the deep drawing, yeah, and the blank holding forcing which is needed on that. Okay, I think I will stop at this point because we are quite late in our time schedule. And if there are any questions, I would be very pleased to answer you them later on.
Thank you very much, Franz. And we will have a workshop to answer the question. Thank you. And I would like to introduce the next speaker, Georg Krauter.
Hello, can you hear me?
Yes, yeah, it's good.
Georg? Oh, sorry. Can you hear me?
Yes.
Yes, okay. Perfect. Thank you, Georg. You can start your presentation.
So I need screen sharing. Let's
yep.
Start. So good morning, everybody from my side. Short introduction. My name is Georg Raut. I'm the first robotics professor, medical robotics professor ever at University of Basel. So the oldest university of Basel also is looking for new technologies being implemented, and now also in the medical field. And this is a little bit, I guess, what is very often missing when we think about Industry 4.0. Usually you think about industrial environment, but there's a lots of data also available in medical field, and it's just very delicate. And what I'm focusing on is in particular working with robots. So this is part of what I'm doing here in the lab, building robotic surgery devices, and basically just data analysis is one point or one part of the digitalization, but actually allowing systems to realize what has been planned, or using the data in a way so that this gets back to the physical world. This is not realized yet, and there's, I guess, also many issues that still need to be discussed. So the project that I'm presenting mainly today is the Miracle project. So we are working on a minimal invasive robot that should do a laser osteotomy based on computer images. So this is one part, and here we are a rather big team, about 50 people, researchers, 4 professors working on this Lighthouse project from University of Basel. So this is one activity of my lab, and I'm also working with bigger systems. So we've developed gait rehabilitation devices together with ETH Zurich and Balgrist in Zurich. Then we also are working. So this basically is focusing on spinal cord injured patients, and here we are also working on stroke patients. Feedback learning, so automated motor learning for humans. So even the digital loop we could close, I guess, as the first research team worldwide where robots train humans. And now we also use artificial intelligence in order to improve bruxism, which actually affects 8% of worldwide population. So it's a rather big problem that generates issues in health. To just give a very short introduction into the different projects that are not in the medical robotics field, but here we have a rowing trainer, so I guess the most sophisticated rowing system in the world that we have been working on, a gait rehabilitation device that we brought to the market already, is sold, and technologies for rehabilitation robotics. And what is common between all the technologies that we're developing is basically that the communication technology. So we are using industrial communication technology based on EtherCAT, We can use the knowledge that we gained on the automation part in research on human movement. We can use that also for developing robotic devices that are useful for gait rehabilitation with incomplete spinal cord injured patients. And so what you see here is a patient running around with this system. It's quite easy to mount this patient, and then she can walk around in three-dimensional space. You can walk stairs, and this is really that's the first device ever on the market that allows such things. So the interaction with therapists is very easy. So that's one of my goals, to make robots be useful very fast. In another application, for example, here, what is new in this application? So this is for stroke patients in rehabilitation, arm rehabilitation. What we developed newly here is a robotic controller that allows the therapist to intuitively provide the support just through touching on the outside. So this is a completely new way of doing rehabilitation, because until now the therapist sat at the computer and just entered or changed the global settings without being able to feel the patient anymore. So actually what they were trained for, and also they are not, or were not able anymore to really interact with the patient and really know what the robot is doing. And we showed that this device replicates the inputs that the therapist provides on the force level along a certain trajectory, so that the patient has the same muscle activation for the same movement. So this is rather new. So and as I initially mentioned, we are also working on bruxism prevention together with the Zentrum für Zahnmedizin in Basel, and with ETH Zurich, and now this researcher Elisabeth, she went even to the Netherlands. So here we already started collaborations with Netherlands. So to go into some projects highlighting our work in medical robotics, I'd like to show you 2 or 3 technologies quickly. On one side, we're working on flexible robotic endoscopes, and here we are interested on one side in visual surveying, so using machine learning technologies in order to, for example, to actuate such a small robotic endoscope with 2 degrees of freedom. It's actuated by 2 DC motors. Here you see we have a control cabinet with EtherCAT communication, and then we have a small camera in this endoscope, and this camera is meant to look at some objects or some tissue inside the patient, and this image is actually registered, and then the surgeon can say, okay, I'd like to focus, for example, on this central spot. So this information is then transferred through an acquisition board to a camera, and then real-time processing. So basically, my focus in the field of artificial intelligence, machine learning, is real-time machine learning. So that, for example, here you want to focus on something, and then this part is moved, and the endoscope just follows automatically without you having to tell the endoscope that it has to move. Of course, this provides some safety issues if devices do work on their own, but that's exactly what needs to be tackled to some extent. We're also working here in that project on making data, so CT data or MRI data, not only visible, so to segment it automatically, but even allow, together with the group of Professor Katta at University of Basel and the Department of Biomedical Engineering, to haptically make this data explorable. So, for example, here we did a CT image of this spinal body, and now in 3D you can see it segmented. You can actually create holes and therefore explore with artificial or with tools that you can program. You can explore now also haptically such systems. Cedric, one of my PhD students, he even develops robots that develop robots. And at the same time, this system can also be used in combination with lasers and regenerative or background in regenerative medicine in order to do ablation of tissues. So to prepare, for example, cartilage for regenerative medicines. So until now, you have to scratch by hand inside a knee joint, for example, until you reach a certain layer, and then you don't know which layer you reached. But since it's crucial, if you get to the desired layer, we can use not only the laser to cut, but use the light that is reflected on one side to see where we are. So just a normal image, but at the same time also to analyze the type of tissue that we are working on. So in real time, we can do an analysis of where we are cutting and which type of tissue we're cutting. And this allows us even with laser without touching, so through such a container, basically a concealed container, to work even outside of biosafety labs, just because we can have the cartilage fixed inside the sterile room, bring this to our lab, and then work in the lab with lasers in order to prepare tissues for cartilage and regenerative medicine. What we also do is we work together again with Philippe Catlin's group on planning and actually interaction with robots in augmented reality. So this image is still with the virtual reality, but so our idea is to have different ways of controlling this robot that will then have an endoscope here, for example, by direct interaction on the handle, by using interfaces like from HTC Vive, this tracker that you could put this tracker somewhere, press a button, and then this means for the robot that it has to go there. But instead of directly going there, the robot would first show you how he would do that in augmented reality, so that you would see are there interactions with the robot and the patient, so you can do not only planning, but also how to move the robot to the right location in such a setting. And then a final project that I would like to show you is we are working in this minimal invasive robot-assisted computer-guided laser stome project. So Miracle, we have to develop a device that is very small and brings laser into the tissue. So this is our current prototype. You see here there's a laser fiber bringing light to the spot. So actually the laser is going downwards. So this system is attached directly to bone, has a footprint of 17 millimeters length and 7.6 millimeters height and width. So it's a rather small device, attaches directly to bone, and therefore is very accurate. So we get results of laser positioning in the 70 micrometer range. So that's the current state of the robotic systems that we are there. So to finalize the image of what we're doing, we try to work on big systems that directly interact with humans, so patients in most of the cases, and we even try to translate this also to the real world. So with rehabilitation or devices like wheelchairs, robotic wheelchairs, and so on. And therefore, in the initial phase of the Cyberthlon, I've been even a CTO. If some of you have watched, this weekend was the Cyberthlon Global Edition. So this happens all 4 years. So this weekend there was this event. So you might have a look at this too. This was really great work, and this is really interesting also for public, because people think that robotics is as far as you can see in Hollywood videos. And then, as I mentioned, some of the projects I'm working also in tiny robotics, construction of robots by robots. So this is the work that we're doing here. And just for you, save the date, we are organizing the first medical robotics week in Basel. So originally it was planned for this year, but as most of you know, things had, so Corona had also an impact on our organization. But next year we'll hold this event. It will be set up as a hybrid event, so you can go there, or you can also watch it online. So there's many different things. So we bring back together two different conferences, MESROP and Automate, a combination between automation and medicine. So medical doctors are very welcome to join also these engineering events. And yeah, that's from my side. Thanks a lot for your attention, and I'm looking forward to the discussions. And in case you have any problems that might fit, we are there for solving them.
Thank you very much, Georg, for your presentation. I think all you three are amazing and doing amazing and futurist things, and much interested. So we don't lose too much time, and we will split into 3 groups, so we can ask everything, can discuss and get more closer to the different opportunity. Thank you very much for your time and discussion. I would like to open the last part of our event, so exchange with participants, and I would like to ask my partners to each provide a short summary of what was mentioned in the discussions group. And I would like to be pleased to answer any question if you have any. So also if you have any point you would like to raise, we will be happy to take them into consideration. So Andre, would you like to start us of some short summary you took from your groups?
Yeah. So I'm going to do a short summary and conclusion. I have to quit in 5 minutes, so I'm going to be quick. So in the group of Mr. Rauter, we talked about different technologies and robotic systems, and also the costs of development. And he told that some devices are driven out of industry, some devices were requested of clinics and the needs from the clinics. Same topic we talked with Professor Quint in the last session. I asked him how, or in which way he gets to know the needs of the industry, and he told me, or he told the group, that a lot still happens by chance, so not in a kind of institutionalized process. And I think this is a part to fortune, to get to get the multipliers in one boat, to institutionalize the process in kind of common or uncommon event formats. And with Mr. Basset, we talked about the problem that often the industrial partners aren't the small and medium-sized companies, but often the big concerns, because they have more money than the small and medium-sized companies. And we talked about the time horizon, and there's often a difference between the time horizon the companies see. They only think about few months or maximum 1 year, and the research institutes or universities think about possibility for projects for more years. And I think there should be a kind of a quick and dirty version with students to get in contact with smaller companies, not for that large amount of money, and for a time horizon that is much more, is much quicker and smaller time horizon. So this was the very short summary of the 3 groups I've been in as a moderation part.
Thank you very much, Andre. So Frederic, what have been happening in your groups?
The time was very short, unfortunately. So I just keep in mind some funny facts. Robots are not intelligent. George told us that robots are not intelligent. We have to put intelligence in them. with IA, and maybe also the fact that this is quite easy to apply it in industry. Algorithm like we saw in RIMAS, or also with vision robotics. There are a lot of new fields in industrial application. So maybe this is the goal we want to achieve together. We first have to really take time to new opportunities in different other universities. I also heard that nowadays there are very few collaboration with German or French or Swiss. So maybe it's a good opportunities for us.
Okay, thank you, Frederick. Karen, would you like to outline the most important points from the discussion?
Yes, I'm not always sure if I was in the right rooms, but I will just sum up the conversation, which was, of course, very short, but nevertheless very interesting. We talked about different things, like, for example, the time framework. What will be the time framework to bring projects to the street? And Professor Quint responded that is very much related to the computing technology they are using. And we also talked about different partners. For example, Professor Quint had also partners, a company, a film company, and also a fashion company, which used the technology to make a kind of virtual dress room, which was also very interesting. But the important message which I heard through the lines was that it's important to have this joint vision in Europe, like, for example, especially between Germany and France, to have a joint vision of some topics like artificial intelligence, and that we also need a little bit a stronger visibility of this project so that we can match better partners with other stakeholders.
Okay, thank you very much, Seren. Is there anything you would like to add? What about the speaker? Is there anything else you wanted to add before the conclusion?
I would be very happy if there would be one or the other, particularly industrial collaboration that can come out. So I'm completely open. So if you want to know more, just contact me. I am happy.
Thank you, Georg. Okay, so we just have 1 minute left for the last slide. I will just share my slides and propose about the outlook on the next planned event online. So I would like to give 30 seconds to Albert to present the next technology circle.
Thank you, Sebastian. So the next technology circle will take place next Monday afternoon at 4 o'clock as a Zoom conference. We will focus on data management, business development, and the impact on predictive maintenance. That's one key area. The other one is related on artificial intelligence to transform the actual workplace into a modern 4.0 workplace. It will be presentations and interactive workshops. So we are happy to see as much people as can. So you're all invited to be there, and looking forward to see you there.
Thank you, Albert. And we'll hand over to Seren for the AI conference.
Yes, you're also all invited to the second AIXA. The first AIXA, first of all, it's a joint French-German event, and the first AIXA, which was a huge success, took place last year in Karlsruhe. And the second AIXA will, of course, because of COVID, of course, will take place online at 3rd December. And it's a really nice event where scholars and experts come from Germany and France and talk about different topics all around artificial intelligence. So you're all invited to join us.
Thank you, Sarah. And,
is it in French, German, or English?
It's in English.
Okay.
Thank you very much, and hope we will see you at the next event. So, as conclusion, I hope the framework of this event provides you with a helpful insight, and I hope you enjoy this event. You are encouraging networking and collaboration, so I wish you get some new idea now, and would you be able to implement this for innovation in the region. Special thanks to our speaker, to my partner, and to the audience, and to Sandra, who work in back office. Thank you very much, and see you soon.